Teachers in Budapest, and I wanted to make sure we were able to bring her to Shanghai. But one of the great things she did as well is she did a parent night in Budapest that I attended even as a parent, and remember thinking, boy, as an educator who's in buildings and schools every day, it's so meaningful to put a hat on as a parent and hear what Erma is about to share with you. As you could tell from the introduction, she's sharing what we call in education the move from what we call procedural math, what most of us probably learned as children, to what we're really trying to move to in what we call concept-based mathematical thinking. It's based on tons and tons of research, and there's probably very few people in the world, except the woman to my left, who could spout off so much of it with from memory. But we're really, really thrilled to have Erma here, and she's been meeting with our teachers over the last 3 days. I wanted to make sure she had an audience with all of you. So, warm welcome to Erma Anderson.
I'm going to talk to you today about why has mathematics instruction changed? Why isn't math taught the way I learned it? Okay? And if any of you have been reading and looking at what's going on in mathematics education, you know there is a movement toward moving away from that total memorization to more automaticity, to really understanding math. So that's what I want to talk to you today about. And why is that important? Well, it's important for a number of reasons, but one of the reasons, I want you to think about this, because we live in a very changing world. The top 10 jobs last year did not exist 10 years ago. The top 10 jobs of last year were non-existent last year. Secondly, our students, your children, my grandchildren will change jobs many times by the time they are an adult. Thirdly, the amount of technical information is increasing at a very rapid rate. And look what it says. For students who are starting this year a 4-year technical degree, half of what they learned in that very first year of study will be obsolete by the time they're in their 3rd year. So stop and think about that. We're preparing our children, your children, for a future that we don't even know what it is. We're preparing them for jobs that don't even exist as we speak. Our very young children, the jobs will change exponentially by the time that they graduate from high school. And so, as educators, as parents, we're really preparing our children for an unknown future. How do we do that? And certainly, one of the things that we don't even have a clue is what were the problems that they'll be solving. But one thing we do know, that mathematics is very important. The ability to reason and understand math is critical, because most of the jobs that will exist in 2020, according to the Office of Economic Cooperation and Development, will be in the STEM fields: science, technology, engineering, and mathematics. They get 75% of all jobs will be in those fields. So how do we prepare children for that future? Why is this understanding of math so important? I don't have to tell you, and many of you may have experienced it. Math can open doors for kids, or it can be a blocking path and prevent many students from pursuing a lifelong dream of what they would like to be when they become adults. So, it can either be a gateway or it can be a locked gate. And sadly, for many children, it is a locked gate. Okay? So, let's talk about that. Because what is mathematics? Why is mathematics important? Reuben Hirsch says, you know why kids don't like math? Because the mathematics that we teach in schools has little resemblance to the mathematics in the real world. It's an impoverished version of what mathematics really is. And it certainly has no resemblance to what mathematicians actually do. So, the teaching of math, the subject of mathematics, has to be authentic in order for students to see its value, to see why it is so critical and so important. Mathematics know-how, this whole idea, is not only one of the most important things that we want kids to be able to do. It's important so that they can have college, so that they can have a good career, or just to be good citizens. I need to understand the math. Secondly, 21st century adults, need mathematics. But the mathematics that they need is not the sort of mathematics that we are currently teaching in our schools. 21st century skills. I've got to be able to problem solve. And problem solving is not doing a worksheet of naked numbers. That's not problem solving. Problem solving actually is really digging into real authentic problems and coming up with solutions. I don't only have to be able to problem solve, I have to be able to reason. I have to be able to collaborate with others. Teamwork is critical. I must also be able to explain my reasoning. I must be able to construct arguments justifying why I've done things. And so, those skills are really important. Joe Bowler, who was at Cambridge University and is now at Stanford, says, it's so critical now that children understand math. Notice I said understand, not know math. Understand math, that she says that many people now refer to it as a new civil right. All children must have access to a quality mathematics program. A quality mathematics program. That's important because what we want is all of our students to be college and career ready. When they leave high school, they should be ready for college or ready to enter the workforce. Well, what does that mean? Here's what the literature says. They got to be able to think critically to be able to solve problems. Critical thinking is absolute in today's society. Secondly, they have to be able to work with teams. Thirdly, I can be challenged and I persevere. I don't give up. I attempt to solve problems and I stick with it. I must have good communication skills. I've got to be able to communicate with others. I have to have confidence in what I do. We must provide students with that confidence and high self-esteem in mathematics. I have to have respect for alternative viewpoints. But look at that last one. I must have strong competencies in math and science to survive in today's world. Those are important. So, what we're saying is, stop teaching so much arithmetic and start teaching mathematics. If you take a look at that, what is arithmetic? When I add, subtract, multiply, and divide, I'm doing arithmetic. It doesn't matter if I'm doing whole numbers. It does not matter if I'm doing irrational numbers. It does not matter what I'm doing, whether it be in elementary, middle, or high school. If all I do is do the basic operations, it is arithmetic, it is not mathematics. Why? Because the definition of mathematics is not defined as doing operations. We're going to talk about that for a minute. But think about this. We teach our students the skills, math skills. They learn how to add, subtract, multiply, and divide, and we beat that into their heads. We take them, and now I get in trouble here, but I'm going to say it. We take them off to Kumon Math so they can memorize those skills and just regurgitate them. That's not mathematics. That is arithmetic. And there is no evidence that having those skills is going to help you when you go to solve problems. We'll talk about that in a minute. Math skills. Why do I learn the skills of mathematics? There is one reason and one reason only. And that is so I can solve problems. It's like being on the soccer field and the coach teaches you some skills. If all you ever practiced were the skills and you never got to perform in the game, it's useless. It's like taking a music class and they teach you all to learn all the scales, but you never get to perform. You never get to play a song. It's useless. Art class. I teach you skills of art, but I don't care whether you can do anything with it or not. Dance, if I never get to perform. We go on in the real world, when we have skills, we do them for a purpose. Skills are to mathematics what scales are to music and spelling is to writing. If all I ever learn are the skills, it is worthless information. However, the objective of learning is to write, to play music, to play sports, to play an instrument, to be in the performance, to be in the concert. And so why do we learn the skills of mathematics? Most children think of mathematics as a whole bunch of procedures. Each year I learn new procedures, but they don't know what to do with them. Because next year I'm going to learn new. I learned whole numbers. Oh, now I'm going to learn fractions. Then I'm going to learn decimals. Then I'm going to go to integers. Then I'm going to go to rational numbers, irrational numbers. So they think every year is a new event. It is not. If we look at all the research out there in mathematics, each year in math builds on what you have learned the previous year. So, what is mathematics? If arithmetic is the basic operations, those procedures that we learn, then what is mathematics? Well, mathematics is defined as a study of the relationship among numbers, shapes, and quantities. And by the way, if you look at the definition, it says mathematics is a way of explaining the phenomena of the world. Think about that. A way of explaining the phenomena of the world. Yes, it uses signs, it uses symbols, and it uses proofs in all of those subject areas. But how does it help me to understand? It is basically a way of thinking. So, get this. The content of math is still the same content my grandma taught in the 20s in a one-room school in Pennsylvania. The content of math has not changed. It's why you can travel around the world as I do and go in schools, American schools, go in British schools, go in Canadian schools, and the content of math is the same. What has to change is the way we apply the mathematics. It's the way we teach it and the way we assess it. That's critical. And Thomas Friedman in 2013, and I like this quote, he said, we can teach new hires the content, and we will have to because it continues to change, but we can't teach them how to think. That's what mathematics does. It allows children to acquire those critical thinking skills that are essential for the world that we live in today. It provides us with all of the skills that are necessary. The ultimate goal of mathematics is really not to prepare them for the IB test, not to prepare them for the AP test. The ultimate goal of mathematics is to prepare them to participate as a citizen and a worker in a very different world than what I grew up in. So, what is it? The international benchmarks, which this school uses, based on a study by APEC, Asia Pacific Economic Commission, of what is the essential mathematics that all students need to know and understand and be able to do in order to function in this modern world. And there's two parts to them. There is content, that's not changed. And there are what we call the habits of mind, or the mathematical practices. And we're going to take a look at those, because those are the things that are needed to develop the 21st century skills. By the way, we've talked about this for how many years? Because we're already into the 21st century. We soon ought to get it right, because it's important that we develop those habits of mind, because they describe what students are doing when they're engaged in mathematics. For example, when mathematically proficient students, it says this, a mathematically proficient student can solve a problem and can persevere. They can be challenged and they stick with it. A mathematically proficient student can reason abstractly and quantitatively. It means they can look at numbers and they can change them into a story. It means you could take a story and you can change it into numbers. It says that a mathematically proficient student can construct a viable argument and justify why they had done something and critique the learning of others. Mathematically proficient students can model with mathematics. We want to talk about that because that's the missing link in math. When children cannot model the mathematics with representations, they lack the conceptual understanding that is going to be essential for the problem solving that will be required in the future. Mathematically proficient students see the structure and the repeated reasoning in mathematics. What I did with addition and subtraction in K1 and 2 is the same thing I do with addition and subtraction in fractions and decimals, with integers, with rational numbers, with irrational numbers. In other words, that's the beauty of mathematics. So what I learned in that primary school of composing and decomposing numbers is absolutely essential for me to move to the next level, which has to do with fractions and decimals and etc. So, what's the big shift in? I said, why is mathematics different, teaching different than when I went to school? Or maybe when you went to school. You're a lot younger than me. But sadly, we still see a lot of people in our schools who were taught math the way that I was. Now, if you look at this, the difference is this. There is a focus. The international benchmarks say at a 4-year-old, and by the way, this is Piaget's research too, a 4-year-old can do this, a 5-year-old can do this, a 6-year-old can do this, and so on, up through to age 12. That's where they're at. We don't try to push it. It doesn't do any good to try to teach me my multiplication tables when I'm 5 or 6 if I don't understand why they work. It doesn't do any good to tell me how to do decimals when I am 6 or 7 years old because my brain's not ready for that yet. Math builds on a progression. It builds on what you've learned the previous year. We're going to talk about multiplication. So that focus is important. What are the critical areas? Well, just briefly. Primary school focuses on composing and decomposing numbers. Intermediate school focuses on multiplication and division of numbers and fractions and decimals. Grade 6 is all about proportional reasoning. Grade 6 moves kids from additive thinking, as Piaget talked about, to the multiplicative thinking, proportional reasoning, which is critical for higher level math. Now, when children don't have that bridge from here to here, it's going to get a big gap, and it's going to come back to haunt us about 10th and 11th grade. A superficial knowledge of the procedures, but not an understanding of why it works. So, that is the stages of cognitive development that Piaget talked about, and our math standards are based upon that research. They're just not built on a whim. They're built on how kids learn math from all of the research that is available. And so, here's an example of that. How People Learn is a great book. How do you and I as adults learn? Children learn the same way. And so, we learn by moving from manipulating things, the concrete, to the representational stage, the picture stage, to the abstract stage. We're going to give an example here in a minute of that. And then here's some other research. Adding it up has been around for about 15 years. It talks about how children learn math. How the brain learns mathematics is about 3 years old, and it talks about how our brain actually functions when it's learning math. all critical for us to understand as parents and as educators of why we do what we do. Why does math instruction look like it does? So if you take a look, there is a coherence across the grades, and I mentioned that. So moving ahead here, so we go to this, and we go here. If I go here, rigor. I'm going to talk to the high school about that this afternoon. Rigor, rigor, rigor. One of the most misunderstood terms in mathematics. Rigor is not about difficulty. Rigor is not about making something harder. That's a no-no term in math. Rigor is not about moving them to the next grade level. That is not rigor. Rigor is defined as a three-legged stool. There's an example. That's a three-legged stool. Rigor. The legs of the stool are this: procedural fluency, conceptual understanding, and application. Well, what does that all mean? If you take a look, there's what it means. A well-balanced math program not only helps children to discover how things work, but why do they work? And where do they work? How are the procedures? That's the arithmetic. The why is the conceptual piece. Why does it work? And where does it work is the application of the math that we're teaching students. A well-balanced math program is rigorous if it has all three legs of the stool. If one of those legs is broken, the gap for mathematics only gets bigger. It never gets any smaller. It widens as children move through the system. So, what is conceptual understanding? Let me ask you this. How did you learn to divide fractions? Don't tell me, just to yourself. How did you learn? Stop and you think about it for a minute. Most of us learn because somebody told us. You invert the divisor, and then you multiply numerator times numerator, denominator times denominator, and you got your answer, but don't forget to reduce it to lowest terms. Didn't know why you did it, but you did it because that's what the teacher told you. Why did you flip it? Going back to third grade, equivalent fractions. When you see this, if all you see is naked numbers, you got a problem. What do you see when you see this? If you thought of a procedure, we got a problem. The literature says when we're talking about fractions, children learn equivalent fractions, and they learn it with a number line. All right, with a bar model. I like the bar model better. It says how many groups of 2/3 are there in a half? That's simply what that says to me. How many groups of 2/3 are there in a half? Oh, I got a half, right? A half and a half, right? How many 2/3 are there? That means I got to divide that again and that again. So how many 2/3 are there in a half? 1, 2, 3. I have a picture. Why? Because the literature says we divide fractions using equivalent fractions. A half is 3 out of the 6 divided by 4. Yeah, divided by 4 out of the 6. So what did I have? 2/3 is 3/4 of my whole. You don't believe me? Okay, try it. The visual model. The visual model. This simply says 3/4 divided by 2/3 says how many 2/3 are there in 3/4. So if I have my 3/4, 1, 2, 3, 4. Would you agree that's 3/4? How many 2/3 are there in 3/4? I have to divide each of those into 3. That's how I get my 12. So I have 9/12 divided by 8/12. I have a little bit more than what? 1 and a little bit left over, 1.9/8. Isn't 9 divided by 8 9/8 and then 12 divided by 12 1? We can get into the why here in a minute, but understanding why, that's what we're talking about. Because conceptual understanding is, let's take a look at another one, multiplication. This one you'll be able to do in your head. What does this mean to you? Let me do it right. What does that mean to you? Don't say 2 times 3 because I can read. It says, I want 2 groups of 3. Do you see 2 groups of 3? 3 people, 3 people. How many people do I have? How many? 6. 6, good, okay. So, I have a picture. But in 2nd grade, we build arrays. We say, oh, but let's take those blocks and let's put them into nice little order of 2 groups of 3. Is that 2 groups of 3? Yeah, it's 2 groups of 3. So then, in 3rd grade, I have to say 5 groups of 7. 5 groups of 7. Do you see the picture? I have 5 groups of 7. I could see 7, 7, 7, 7, 7, which is 5. Or I could see my array in my head, which is 5 and 2 and 5, which is what? 25 and 10 more. It's a distributive property. I can break them apart. That's what they taught me in primary school. That's why they spend all that time. Because now, when I look at this, this is a distributive property. This really helps me when I get to algebra. But I understand what multiplication is. What about, oh, by the way, do you know the only multiplication facts you ever need to memorize are your 5 by 5s? That's a literature. 5 groups of 9 is what? 5 groups of 5 and 5 groups of 4, right? Isn't 5 and 4 9? Isn't 5 and 4 9? Yeah. If I have 9 people in a row and I have 5, I could split and put an owl here and here. So 25 and 20. It's understanding the why. This is how we get to automaticity, not through memorization. Look at the definition. Automaticity is what we have. Memorization is very fragile. And this is why if you have students in middle and high school who might be struggling, it was fragile acquisition of a lot of facts that had no meaning. Think about it. Why? Because, let's move ahead. Let's jump real quickly to 4th grade. Ready for, well, that's 3rd grade. What does that say? 3 groups of 18. 3 groups of what? 10. 3 groups of 8. 30 and 24 is what? I'll just write it down so you see what I'm doing. Right? 30 and 24, isn't it? Isn't that what it is? Okay, 54. So, what about 8 groups of 56? 8 groups of 50 and 8 groups of 6. 448. Not how I was taught, remember? Oh my gosh. No, I'm going to do this one. Now I'm grade 4. What does that say? You're allowed to talk to me. 22 groups of 23. Do you have a picture? 23 groups of 22. 23 people in a row and 22 groups. Oh, that's 230, 230, and 46 more. Right? Or I could go like this. That whole area model, which we just had to talk about with a high school teacher who shared something. And you see there's the distributive property. Do you ever see that again? You better believe you see that again all through middle school when I'm solving x plus 2 times x plus 3. It's the same principle. It's my 4th grade math. It's not new. That's why we know middle school teachers, they teach nothing new. They only build on what elementary has done. Now, are you ready? All right. Now I get to decimals. Decimals. 2 1/10 times 3 4/10. You should do that in your head. What does that say? I want 2 1/10 groups of 3 4/10. Students who have been taught these methods says, oh, that's a whole, and 1, 2, 3, 4/10, right? Do you see my 3 4/10? What does this say? I want 2 groups of it. There's another group. There it is. How much do I have? I have 6 8/10, don't I? But I want 1/10 of that, 1/10 of that, 1/10 of that, 1/10 of that, 10, 10, 10, 10. There's my answer. My answer is what? 6 8/10 and 3/10 and 4/100. 7 14/100. Understanding what multiplication is. The area model, the distributive property. We just don't memorize those properties. We use them to construct our understanding of what they are. That's why we're saying math instruction has to change. Doesn't do any good to learn like I did, 23 times 36, 6 3s is 18, carry the 1, carried is not a mathematical term, it is not in the mathematical dictionary, and so therefore, I put a 0 there, didn't know why I did it, but my teacher told me I had to put it there, so I put it there, and I got a 9, and I got a 6, and I add them all up. Never knew why I did it, but I did it because that's what I was told. I learned a procedure without meaning. Think about it. Think about why kids hate math. It doesn't make sense to them. It's just a bunch of rules, and the rules change. What I do here is very different than what I do there. But that's not true. I use the same thinking because that's the repeated reasoning in mathematics. So what is conceptual understanding? When knowledge is learned with understanding, it is a basis for acquiring new knowledge. It is so critical that children learn to compose and decompose numbers in primary school. Because even Piaget said by age 7, they will have fluency, which I'm going to talk about in a minute, of basic addition and subtraction of single digits by age 7. The brain research today is the same. That has not changed. So, how do I do it for understanding? That's where these pictures comes in. It's very critical that children can model with number lines, the bar model, the area model, their understanding of why it works. And so, solid conceptual understanding, it's more than about the answer. It's the journey you take to get to the answer. And so this is why we ask students, explain your thinking. Construct an argument of why you did what you did. It doesn't do any good to teach me a mnemonic for the distributive property. Teachers say to students, oh, well, you distribute it. Well, what does that mean? Because usually I distribute it at 3, but I don't distribute it there because I don't know what that means. When literally that's what my third grade teacher taught me, that says I want 3 groups of x plus 2, x plus 2, x plus 2. So I have 2 x's and I have 4. But if I learn it as a procedure, it doesn't make any sense to me. So, conceptual understanding supports children's